Hi everyone, we will be discussing AppArmor and web system hardening and the best security practices. Okay, so AppArmor is a Linux security system that protects applications and the operating system from threats, including zero-day attacks. It has mandatory access control, complements Unix permissions, and has been in the kernel since the version 2.6.36 and is supported by Canonical since 2009. AppArmor profiles access to security rules for each application, controlling access to files, networks, and system features. They help prevent malware from harming the operating system and are stored in the --etc-apparmor.d- directory. It's easy to manage and update security rules from the directory. So AppArmor in the Linux kernel is pretty much the same thing. It uses mandatory access control. It's integrated into the Linux kernel, supported by Canonical, and it adds that extra layer of security. It complements existing permission systems. With this, it mitigates the zero-day attacks and defends against external and internal threats. To check AppArmor's status, the profile status, you need to open your terminal and run the AppArmor status command. Type it in the terminal, sudo aa-status. Review the output for the number of loaded profiles, and this will ensure that you use administrator privileges for access. You need to use sudo. If you don't use sudo, you're not going to gain access. It's just one of those things that it requires that extra security to ensure that not anyone is accessing this information. It's required. Next, we're going to be discussing hardening recommendations for AppArmor. To maximize AppArmor's effectiveness, enforce profiles on network services, regularly review logs, and use complaint mode for safe testing. Combine AppArmor with tools like firewalls, fail2ban, and audit-d for comprehensive security. So what is HTTPS and why is it important? HTTPS stands for Hypertext Transfer Protocol Secure. It is the main protocol utilized to transmit data between a website and a web browser. HTTPS encrypts data to enhance the security of information during transmission. This is especially crucial when users send sensitive information, such as when accessing a bank account, email service, or health insurance portal. Anything that can be deemed sensitive, even login information. Also note that this is widely adopted for online security all across the board. It's a standard practice for secure websites. If you see that little lock symbol all the way at the top corner, you know it's HTTPS, encrypted, it's secure, your information is safe, and you should have no worries if the hacker is getting your information. Next, we will discuss how HTTPS encryption works. Well, HTTPS secures communication using two keys, a private key kept by the server and a public key shared openly. The public key encrypts data, which only the private key can decrypt, ensuring privacy and secure exchanges online. You need that, you want that, especially when shopping online. You don't always get the ability to use Apple Pay, right? Sometimes you have to input your card information, and you want to make sure when you input your card information for paying a bill, paying your medical bill, that you're utilizing the HTTPS encryption, that site has that little lock in the corner, because if not, you may not want to input your card and just double think about your decision and find another website that does have that encryption, that SSL certificate. You want to make sure that that website has that. Next, we will discuss HTTPS hardening recommendations. You want to ensure that the firewall is properly configured. A poorly configured firewall is equivalent to having no firewall. You might as well not even have one. You must ensure that all the proper rules and configurations are regularly updated on an as-needed basis. Utilize the principle of least privilege concept when setting up super user and administrative roles. This is key. Needs to limit administrative access to only those who need it and ensure that the accounts are consistently monitored. Use a patch management tool to regularly apply updates and patches to the operating system. This ensures the system stays updated and secure automatically, eliminating the need for constant manual checks and updates, saving you both time and hassle. Next, we'll talk about configuring HTTPS on web servers. We will configure our servers using two main applications, IIS for Windows and Apache for Linux. IIS is designed for Windows environments, while Apache is popular in Linux. Both serve as web servers, enabling a website and application hosting. HTTPS secures data by encrypting transmissions between websites and browsers. That's crucial for sensitive tasks. While HTTP forms the basis of web communications, transferring information via hypertext links. HTTPS differs by adding encryption, while HTTP does not. Common HTTPS uses including banking and email, while the HTTP exchanges involves client requests and server responses. Internet Information Services, IIS on Windows, is a secure, flexible, and easy to manage web server. Its scalable architecture supports everything from media streaming to web applications, making it capable of handling even the most demanding workloads. It's ideal for web applications, supports media streaming, scalable, flexible, easy to manage, is everything that you want and need. IIS hardening recommendations would be authentication and authorization, SSL, TSL encryption, and web application firewalls. The web application firewalls, it adds that extra layer of security by monitoring HTTP traffic. You want to filter and analyze the traffic in real time to block the threats, and defend against common attacks such as SQL injection and XSS. To configure IIS to enable HTTPS, you need to open the IIS manager and select the site. Then double-click on SSL settings in the features view. Check Require SSL, then click Apply. This will redirect all the HTTP traffic to the HTTPS, the encrypted site. You need that. You want that. You want to make sure that your information is encrypted and secure and that no hackers can have any ability to access your sensitive information. Some advantages of the IIS architecture is newer versions. They use a modular design. It brings three main benefits. You can install only what you need, easily extend or customize features, and enjoy smooth integration with ASP.NET for better web application support. That's exactly what you want. The Apache Web Server is a widely used platform for hosting websites and files. It's simple to install and configure, but its default settings aren't that secure to fully protect the site. So security improvements are recommended. Default settings, they may lack that strong security, but the installation and configuration are straightforward. We'll discuss more. One of the hardening recommendations to secure Apache is by hiding the Apache version and operating system information. The Apache web server displays the version used if you accidentally browse the wrong URL of a website by default. It lists the IP address, host operating system, Apache version, the port, etc. To ensure your browsing experience is secure from hackers, you must open the default Apache configuration file on Linux to hide your information. You will access the configuration file on Debian, Ubuntu, or Mint. Open it using that code, that etc. Okay, you'll use sudo vim for editing. Then configuration changes, you need to set server tokens to limit information disclosure. Set server signature to off to remove server signature from pages. Then apply these changes. Save the configuration file after editing, and boom, it's done. You'll reload the website you're trying to reach. Your web server information should not be displayed. The second hardening recommendation to enhance security is to frequently update Apache. This ensures that we see the latest security patches and bug fixes to keep your data safe and secure. This helps reduce risk of unauthorized access and hackers from stealing your sensitive information or even your browsing information. The third hardening recommendation is use HTTPS encryption on Apache. By default, HTTP protocols used on Apache, which is not secure. Encrypt your desired site using an SSL certificate. Doing this will switch the default HTTP protocols to HTTPS. You want that S. You want that extra security. S stands for secure, security. You need that. You want that. You want your information not to be leaked out to these hackers. You want it to be encrypted. You need that extra layer of security. You want to make it hard for them to intercept any information being sent from the server. Another great hardening recommendation is to enable HTTP strict transport security, HSTS. For Apache, implement the HSTS web security along with the HTTPS encryption for the most secure connection to the server. HTTP strict transport security is a security policy that safeguards websites against man-in-the-middle attacks and cookie hijacking by preventing attackers from forcing a downgrade from HTTPS to the less secure HTTP protocol. So let's understand HTTP protocol. The Hypertext Transfer Protocol, HTTP, is the web's foundation. It's used to load web pages through hypertext link. It's an application protocol that enables information transfer between devices on a network, operating above the lower layers of the network protocol stack. In a normal HTTP exchange, the client sends a request to the server, and the server replies with a response. Some hardening recommendations for HTTP would be to enable HTTP strict transport security, remove unnecessary web server modules, and modify default configuration settings. Let's discuss the importance of browser updates for security. Regular browser updates enhance security. It safeguards the sensitive information, preventing unauthorized access, mitigating and reducing that risk of data breaches. It ensures optimal browser performance, improves speed and reliability, and supports new features. It also stays ahead of emerging threats. The key is to always, always, always update your web browser to ensure you're benefiting from the latest security patches and protecting your sensitive information. So there are some key differences between HTTP and HTTPS. HTTPS is encrypted. It uses that SSL certificate, where HTTP uses plain text. HTTPS utilizes a 443 default port, where HTTP uses port 80 as default. HTTPS, the secure one, is faster, it's more optimized, where HTTP is slower, especially on older systems, it's not the best. Lastly, the best case scenario that you'll want to utilize both HTTPS and HTTP is HTTPS is better used for sensitive data, logins, payments, things of that nature, where HTTP more so public, non-sensitive data, non-invasive. So let's discuss the analogy between HTTP versus HTTPS. HTTP has open communication, where HTTPS is secure transmission. HTTPS protects sensitive information. HTTP exposes data to potential interception. In the real world, you can use this analogy where HTTP is like a readable postcard. It's like sending a postcard where anyone that handles it can read your message. Whereas HTTPS is like sending your message in a locked box that only the receiver can open. I like that option. Well, we're at the end here. These are my references, and further reading if you like. There's a list of everything that I've used. I wanted a thorough overview and understanding of the security protocols and any hardening recommendations that I can add for myself. I use Windows all the time. What do you guys use? Let me know. Let me know in the comments. Posting this on D2L. So yeah, if you made it this far, 15 minutes, let me know, do you use Windows or Linux more?